Hello dear students, today I will discuss about expectation, mathematical expectation of random variable and also moment generating function. So I think in the previous class expectation about expectation of a random variable I have already discussed with you. Expectation of a random variable. Random variable may be discrete random variable, continuous random variable. Continuous means integration is used, and discrete means summation is used. Okay. So suppose x is random variable. You know random variable what? Can take real values. Clear? So first of all we have to identify what will be the random variable. If discrete, then we use sum of xi pi, summation taken over I, expectation of x. Also for continuous random variable, minus infinity to infinity xi fx dx, where fx is PDF, probability density function for the distribution. Okay, probability distribution, we know what probability distribution. Random variable takes values x1 up to xn, and probability, corresponding probability for x1 p1 p2 p3 up to pn. For discrete random variable, discrete distribution, and pdx fx pdf for continuous random variable. Okay, so expectation is just like this. Also expectation of sum of random variable, up to n. So what? Separately you can add, like this, just like this. Okay, up to n. And also multiplication of variable x1 x2 up to xn can be write like this when these random variables are independent. Okay, so expectation x2 up to expectation of xn is independent random variable. This type of formula we know from previous class. Okay, expectation for discrete, for random, sum of variables, expectation of this, that means separately write expectation and sum of. Here the product of random variables, expectation of this is equals to product of their expectation if random variables are independent. And here pi means for discrete, probability corresponding values of the random variable. Fx means what? Probability density function for continuous random variable. So this is expectation, this is sum of expectation, this is product of expectation of product. Okay, so these formulas are used, I will use now for solving 2-3 questions. Okay, and then I will discuss about moment generating function. Okay, so by using these formulas of expectation, mathematical expectation of random variable, just we have to solve 2-3 questions. First questions: what is the expected value of the random variable number of points What is the expected value of the number of points that will be obtained in a single throw with an ordinary die? Find the variance also. Expected value of number of points on obtained in a single die. Single throw with a ordinary die. Die, you know, 6 faces are there. Die can be thrown, single throw, only single throw. Then we get numbers on the top face. What? Maybe 1, 2, 3, 4, 5, 6. These are the number of points getting obtained on a die of single throw. Okay, so what is the expectation of that number? Okay, for finding expectations, first of all, we require random. What is random variable? Clear? And what is the probability for values of random variables? Here, suppose x is variate variable, that means suppose, so solution we can write, let x be the variate. X means what? Random variable takes numbers. So x can take value 1 or 2 or 3 or 4 up to 6. So let x be the variate. You can also write variate variable, variate which shows the number, obtained, which shows the number obtained on the top face of die in a single throw. Okay, single throw. Then x can take values 1, 2, 3, 4, 5 or 6. Variate shows number getting on top face in a single throw. Okay, and for a single throw, the probability of getting any of this number is or we can write like this 1 by 6, because there are 6 faces. So 6 faces, total number of faces, and getting only single number on top is, so getting any of this number means 1 by 6 probability. So for single throw, the probability of getting any of this number is 1 by 6. So the probability distribution of x is given by what? X taking 1, 2, 3, 4, 5, 6, and probability is given 1 by 6, 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 1 by 6. These are the probability, these are the values of the random variable. Okay. Now we have to find what? Expectation, and then also variance also. Okay, expectation, we know also that mean means this shows what? Mean. And variance means what? Variance mu2, that is mu 2 dash minus mu 1 dash square, or we can write variance of x equals to expectation of x square, expectation of s square, expectation of, we know also this formula, minus expectation of x square. Both are same, formulas are there, we know. Variance means expectation x square minus expectation x whole square. Mu2, that is variance. Mu2, moment about mean. Okay, so mu2 variance of second order moment. Mu2 dash second order moment about origin. This is mu1 dash first order moment about origin square. So this is mu1 dash, here mu1 dash means what? Mean, expectation. These are formula, okay. Dash means about origin. Okay, these are the formula. So we have to find now expectation x and variance x. Okay. Now we have expectation of x is what? Sum of xi pi. This for discrete distribution, this discrete distribution, random variable takes values, discrete values 1, 2, 3, 4, 5, 6. So discrete means summation, continuous means the value of x lies within an interval, then we will use integration. So here this is equal to xi pi means x1 into p1, x2 into p2, and so on. So we can write like this. This is equals to x1 p1 plus x2 p2 up to what? xn, yeah, 6, x6 p6. Okay, so this is equals to 1 into 1, 1 into 1 by 6 plus 2 into 1 by 6 plus up to 3 into 1 by 6. So we can write 1 by 6 common. So 1 plus 2 plus 3 up to what? 6. Okay, so we know the formula for 5. Suppose 3, then 4, then 5. 1, 2, 3, 4, 5, 6. Now this is equals to what? 1, 2, 3, 3, 6, 6, 6, 12. 12 and 16 and 5. 21 by 6 equals to divided by 3, 7 by 2. This is expectation of random variable 7 by 2. This is our answer, expectation. Now we try to find also what variance of x. Variance x equals to last formula we can use. It means expectation of x square means just a square of it and multiply to here. That is here square. Okay. So this is for a single throw of a die. The expectation of random variable is this. Clear? Now, for finding variance, this is expectation, okay? 7 by 2. Just we get expectation 7 by 2. Okay. Now, also, we have, first of all, for variance, we have to find this. Expectation of x square means what? Sum of xi square into pi. That means what? x1 square p1, x2 square p2, up to x6 square p6. That is what? 1 square into 1 by 6, 2 square into 1 by 6, up to 6 square into 1 by 6. So we can take common 1 by 6, 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square. 1, 2, 3, 4, 5, 6 square. Okay, so this is equals to 1 by 6. Now 1 square, 2 square, 3 square, just we can calculate it. Okay, by formula or as you. What will be the value? 1 square, 1 plus 4, 5, 5, 9, 14, 16, 25, 36. Okay. $91. Okay. The sum of this is 91 into 91. Clear? That is what? 91 upon 6. Clear? Now, this is expectation x square. Therefore, variance of x equals to expectation x square minus expectation of x total square. So this is square 91 by 6 minus expectation of x 7 by 2, 7 by 2 square. So 91 by 6 minus 49 by 4. Now we can calculate it. $12 and 2 minus 147 35 by 12. So 35 by 12. 35 by 12. Now here 35 by 'So this is the value of variance and this the value of expectation is this. So remember this formula. Okay, variance is this. Also in terms of moments you can use this formula. Expectation x means mean. As here we just first find expectation of this random variable. First of all, we have to decide what is random variable, what is the probability function for that variable. Okay, then you can get for discrete distribution. Here is discrete distribution, so we use this formula and get this. Okay, now take second questions. Okay, questions, that is in 4 tosses of a coin, let x be the number of heads. Calculate the expected values of x. Means we toss a coin 4 times, and in 4 tosses, the number of heads that can we get. What is the expectation of the number of heads in 4 tossing of a coin? Okay, so number of heads, a coin, if a coin is tossed 4 times, then number of heads, what may be the value, what may be the number of heads? Just throw a coin. Okay, then 4 times, so number of heads maybe in all tosses heads are getting, so number of heads maybe 4. Also maybe number of heads 3, 2, 1, and no heads 0. That is, if we denote x as a number of heads in 4 tosses of a coin, then x can take values 0, 1, 2, 3, 4. Clear? Now take another question. In 4 tosses of a coin, let x be the number of heads, then calculate the expected value of x. Okay, so solution number of heads in tossing of a coin 4 times, 4 tosses. Okay, so here if x denotes the number of heads getting in 4 tosses of a coin, then the values taken by x may be what? 0, 1, 2, 3 or 4. 0 toss, 0 head, 1 head, 2 head, 3 head, 4 head. Okay, that is x, values of x are 0, 1, 2, 3, 4. Now we have to find probabilities corresponding to these values, these values, these values, these values, and these values. Okay. Now, probabilities of x equals to what? 0. Probabilities of x equals to 0. Clear? Suppose 4 time tosses, that means first 1 by 2, second 1 by 2, third 1 by 2, fourth also 1 by 2. toss coin, then getting no heads means getting tail or head. Probability 1 by 2, 1 by 2. So getting tail simultaneously, and this type of combination may be 4C 0. We can 4C 0 means 1. 4C 0 means out of 4, 0 success, 0 head. You can take this is the probability of head, getting head or tail is 1 by 2. So x equals to 0 means 4, 1 by 2 into 1 by 2 into getting heads. So 0 heads. This is a 4 heads, getting 4 heads probability. We can write like this. Getting 0 head. This is equals to what? 1 by 60. Clear? Px equals to 1. X equals to 1. 4C1 getting 1 by 2, 1 by 2, 1 by 2, because getting head or tails are same. So 1 head. But 4 time tossing, but in which time get head? So out of 4, just 1. Out of 4, just 1 head is getting. Okay. So this is equals to 4C1 means 4. 4C0 means 1. 4C1 means 4. So 4 by 16 equals to 1 by 4. Okay. Now, similarly, Px equals to 2. We can find 4C2. 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2 equals to what? 4C2 means, solving this factorial 4 upon factorial 4 minus 2, 2, 2. So 4 into 3 into 2 into 1, 2, 2 cancel, 2, 2, 2, 6. 6 by 16, that is by 2, 3 by 8. So this is equals to what? 3 by 8. Okay, 3 by 8. You can solve it. Now P x equals to 3. 4C 3. 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. This is equals to what? 4C3 means also 4. 4 by 16 equals to 1 by 4. And finally, all heads. 4C 4 out of 4. 4C 4 out of 4 head. 4 head is getting. And 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. This is equals to also 1 by 16 because 4C 4 equals to 1. Okay, so 1 by 16. Clear? These are the value. So you can write thus probability distribution of probability distribution of x is given by x 0, 1, 2, 3, 4 and probability Px first probability 1 by 16, second 1 by 4, third 3 by 8, 1 by 4, 1 by 16. So this is probability distribution. For each questions we have to find values of random variable and its corresponding probabilities. That is the probability distribution. Now from here we can find expected value of x. Expected value of x, random variable. Okay. So here expected value, you have to find expected value. Now we see that the expected value of x is expectation of x is equals to what? Sum of xi pi I x1 p1 plus x2 p2 as the same process. Okay, x, how many values are there? 1 2 3 4 5. So x5 p5. So we can write first value 0 into 1 by 16 plus 1 into 1 by 4 plus 2 into 3 by 8 plus 3 into 1 by 4 plus 4 into 1 by 16. Now we can calculate it. 0 plus 1 by 4 plus 3 by here plus 3 by 4 plus 3 by 4 plus 1 by 4. Okay, so here 1 2 3 4 means 4 1 plus 3 plus 3 plus 1 equals to 4 4 8, 8 by 4 equals to 2. So 2 is our answer. Expectation of x, expectation of random variable x is equals to 2. Okay, so expected value, required expectation, expected value is 2. Clear? 2 is the answer. So main thing is what? Just you have to decide what will be the random variable and for its corresponding values what will be the probability. So first of all you have to write distribution, then you can find expectation. Okay, and take another questions for solving, like sum of expectation of sum of random variables. What? The sum of their expectations, we know. So take another question. Suppose take a question here. What? A box contains A white ball and B black ball and C balls are drawn. That is a general number, and show that the expectation of the number of white balls drawn is C upon A plus B. Suppose there is a box contains A white ball, A white and B black ball. This box contains. So total ball is what? A plus B. And we draw C balls, the counting up to C, 1, 2, 3 up to C. C balls drawn from here. What will be the expectation of getting white ball? Number of white balls. How many numbers? How many balls are drawn? C balls. Just like for example, 50 balls are drawn. So out of 50, what will be the number of expectation of getting white balls? Here in general, A white balls, B black balls. Just drawing, number of drawing balls is C. Then the prove that the expectation of getting number of white ball is, if we draw C balls, then CA upon A plus B. This is the, we want to prove like this expectation. So first of all, we have to decide random variable. Okay. From here, for particular case, suppose one ball is drawn out of total ball A plus B, A white ball, B black ball. One ball is drawn. If ball is drawn ball is white, then probability will be A upon A plus B. Similarly, for black ball, B by A plus B. But we require white ball. So suppose our random variable is x, I equals to 1, 2, 3 up to C. I equals to 1, 2, 3 up to what? C number of balls. Suppose first drawing x1 is white. Then take its value as 1. Second drawing also 1. Then take its value is 1. If in third drawing, if x3 equals to black ball, then 0. For black ball, xi equals to 0. For white ball, xi equals to 1. We can define random variable like this. Now, number of white ball, how can we get? In this 3 drawing, number of white ball is 2 by adding this. So, if xi, these are the number of, this denotes the number, okay, its values are like define what, xi equals to 1 if white ball getting, 0 if black ball getting. Then number of white ball, sum of xi. Sum of xi. Sum of xi means x1 up to xn. Now for a particular value x1, what will be the expectation? For a particular value, what will be the expectation? Clear? Expectation of what? X. Okay. Because we know sum is total number of white balls. So sum, expectation of this sum is equals to expectation of their separately sum. Sum of their separately expectation. So expectation of x1, expectation of x2 and so on. So we will try to find xi equals to, when xi equals to what? 1 plus 1 expectation. Probability this, and probability when xi equals to 0. Clear? So here for solving this, just first we will write random variable. Okay. So for solution, consider the random variable. Consider the random variable xi as xi equals to 1 and xi equals to 0 if drawn ball is white and if drawn ball is black. Xi equals to ith ball. If white, this drawn ball is white in ith drawn. In ith drawn. Ith drawn means first drawn, second draw, third draw, fourth draw, and so on. Okay, just we define like this. Okay, random variable. Clear? Then we consider a random variable xi as xi equals to, if I had drawn getting white ball, then value is 1. If in I had drawn drawn ball is black, then 0. Then if we draw C balls, then I equals to 1, 2, 3 up to C. Because I have drawn C draw. C time draw. We draw. Okay. If we draw C balls, then this. Then and total number of white ball drawn in C draw is given by x equals to x1 plus x2 plus x3 up to xc. Clear? Therefore, expectation of x is equals to expectation of x1 plus x2 plus x3 up to xc is equals to expectation of x1 plus expectation of x2 plus expectation of xc. We know expectation of sum of random variable is the sum of their expectations. Okay. Now we have to find expectation of xi, that is expectation of corresponding values. Okay. Now probability of drawing. Now probability of drawing one white ball is Px equals to xi equals to 1, because we define 1 means xi equals to 1 means probability drawing one white ball. Okay, white ball. So probability of drawing one white ball is, this is equals to what? A upon A plus B, and probability of drawing one black ball is xi equals to 0, B upon A plus B. Drawing white ball, drawing black ball, probability of like this, x equal to 1, xi equals to 0, this. Now this is our question 1. Suppose now we will find expectation of xi. Okay, for each case what will be the expectation? So here we have expectation of xi, expectation of xi is equals to what? probability of xi may take value what? 1 into x I, or we can write its value 1 plus probability of xi equals to 0 into 0. That is probability of this a upon a plus b into 1 plus b upon a plus b into 0 equals to a upon a plus b. Clear? A upon a plus b implies expectation of xi equals to for all I. Clear? That is independent of I. This is independent of I. For all I, this. Clear? Now, we use this for finding or expectation of from equation 1 by using this. Okay. Thus, from equation 1, we get the expectation of number of white ball. Number of white ball drawn in C draw is expectation of x equals to expectation of x1 plus expectation x2 and so on. Expectation of xc is equals to what? First, for every I, value is this: a upon a plus b, a upon a plus b up to c times implies c a upon a plus b. So this is our answer. Okay, expectation of x. Clear? So main thing is what here? Main thing is that we have to decide what will be the random variable, and for corresponding values of random variable we have to find probabilities, and then we can get expectation. Okay, so this is the for using formula for expectation of sum of random variables equals to sum of their expectations. Okay, now here take another question. Find the expected value. Find the expected value of product of points in n dice. Okay. Here what is given? Expected values of product of n points. Expectation of product of n points on n dice means suppose n dice are thrown. Okay, now product of points on n dice 1, 2, 3, 4, 5, 6, 7 up to n dice. Suppose ith dice denote xi number. ith dice, xi number. First dice x1. Number on the dice. First in the first dice x1. In the second dice x2. In the third dice x3. And the nth dice xn. Okay. Then we have to find the product, expectation of product of these numbers. Okay. So here we can suppose that the xi as a random variate which denotes let xi denotes the variance that shows the numbers on dice, and in a particular dice number may be 1 2 3 4 5 6 in a particular dice. Okay, so xi denotes the variates that shows the numbers on ith dice from n dice. Then variates will take values x1, x2, x3, xn. Okay. Variates denotes the numbers as this. Okay, variates. Clear? These are the numbers. We have to find what? Expectation of product of points. We have to find expectation of x1 into x2 into x3 up to xn. Here, since getting numbers on a die is independent, therefore expectation of x1 into x2 into x3 into up to xn equals to expectation of x1 into expectation of x2 into expectation of x3 into up to expectation of xn. Clear? And also we have the expectation of getting any of the numbers 1 2 3 4 5 or 6 in a die is expectation of getting any of the numbers 1, 2, 3, 4, 5 or 6 in a die is as follows. Expectation of xi equals to what? 1 into 1 by 6, 2 into 1 by 6, 3 into 1 by 6, 4 into 1 by 6, 5 into 1 by 6, 6 into 1 by 6 equals to what? 7 by 2 for all I. Clear? For a particular dice, expectation of getting any of the number on top face is 7 by 2. Clear? Thus, by using 1, this is 1. By using 1, the expectation of product of points on n dice is expectation of x is equals to expectation of x1 into x2 xn equals to product of 7 by 2, 7 by 2, 7 by 2, 7 by 2 n times. This is equals to 7 by 2 n. Okay. This is the answer. Expectation of product of getting numbers on dice is 7 by 2 power n. So this is the formula for independent random variable like this. Expectation of product is equals to product of their expectations. Okay. So this is solution of this question. Okay. So expectation of product of random variables equals to product of their expectations in case random variables are independent, and also in the previous questions expectation of sum of random variables equals to sum of their expectations. Okay. So now time is for your questions for your attendance. Okay. So you have to solve only 2 questions I will give to you for your attendance. Just solve this and send me. Okay. So first question is, a box containing 5 black, 6 white, 7 red. Okay. First question. A box contains 5 black, 6 white. 5 black, 6 white, 7 red balls. 5 black, 6 white, 7 red balls. 4 balls are drawn at random from it. 4 balls are drawn at random from it. If X denotes the number of white balls, if X denotes the number of white balls, then find expectation. Then find expectation of X. Okay. The second question is, just we have to write first question here. If n fair dices are tossed, n fair dices are tossed, okay, and X denotes the sum of points on, and X denotes the sum of points on, X denotes the sum of points on n dice. N dice. Find the expectation of X. Find the expectation of X. Okay. So these two questions you have to solve and send me PDF file for your attendance. Okay. So very simple questions, I think. You can solve it very simply, because here X denotes the number of white balls. 4 balls are drawn. Okay. So how many balls are there? Here X is the number of white balls. Clear? Number of white balls, you have to find number of white balls, expectation of number of white balls. Okay. So if 4 balls are drawn, four balls are drawn, so how many? What will be the values of random variable if X denotes the number of balls? If X denotes the number of white balls in 4 balls drawing, so maybe 0 white balls are drawn, 1, 2, 3, 4. That means here X can take values 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay. 0, 1, 2, 3, 4. Now you have to find the probability distribution. Here, 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 here. You have to find the value. How can get Px equals to 0? That is, no white balls are drawn. That means total probability, what? How many balls are there? 5, 6, 11 and 18. So 18C 4 in denominator, total number of cases. And numerator 5 and 7. Okay, so no white balls, no white balls. That means 6 is 0 and 7, 5, 12 remaining, getting from 12 ball. 12C 4. 6 is 0, 12C4. Because no white ball. This is 4 ball from remaining 5 and 7. And total balls are this. Similarly, for x equals to 1, 6C1, 1 white ball. And remaining 3 ball are drawn from other. Okay. 12, so 3 and 6C1. Just you can get the values. You can solve NCR. Formula is what? Factorial n upon factorial n minus r into factorial r. Okay. So, for 1, this. For 2, this. This. For 3, this. And 1. For 4, this and 0. So, you can get this, and then use the formula expectation. Expectation of x equals to what? Summation xi and pi. You can get value. Clear? So do it in your copy, okay? And send me PDF file. Also, it can be find here n fair dice are tossed and find the expectation of x denotes the sum of. So suppose x1 plus x2 up to xn. So expectation of this is equals to can be used expectation x1 plus expectation of x2 plus and so on up to expectation of xn. You can get the value. For a particular dice, what will be the value? Expectation. Fine. And then put here values and you can get the result. Okay. So very simple questions. Very simple questions. Okay. So do it. For a particular dice, you have to find first this, then use that value in everywhere up to n times. You can get the result. Okay. So send me solution of these two questions. Okay, for your attendance.